Relax, but later we'll have to do some mathematics, right? What you have here is the thing I did not have time to show you before. If you want to have a look at that, we have our YouTube channel with a large number of videos, but in particular, this is a playlist done by our students on several outreach presentations, and one of them is this one on what are complex systems. It is in Spanish, but it is subtitled in English, so you can, and I think many of you understand Spanish. Okay. So, first talk was about physics of complex systems. At the beginning, I talked about this interdisciplinarity in physics, and what I want to do now is to tell you a little bit about what is this interdisciplinary adventure of taking statistical physics to the study of social dynamics, okay? Again, it will be a little bit blah, blah, blah. I will start with a joke, which is in Spanish. I'll translate. This is not of the last economic crisis, but the one, I don't know, in 19-something. I mean, you know, this financial crisis appear from time to time. And it says, the money that we are losing in the stock market, where does it go? Nowhere. It evaporates. And this doesn't go against the laws of physics? Yes. But economy is not a science of matter, but a speculation of the spirit. And this is something which many physicists think about, that one cannot do science about that. And it goes on the idea of what is physics, and if physics is part of natural science. I already discussed before what is this idea of what is physics. I can tell you by a personal experience that I spent quite a few years of my life doing laser physics. And that when I gave a talk of laser physics in front of an audience of physicists, never, no one asked me, why are you doing that if this is not natural science? Because there are no lasers in nature. But when I give a talk in front of physicists about social system, they normally ask, what are you doing that if this is not part of natural science? And I might be very stupid, but if we are not part of nature, what are we? So I claim we have the right to study ourselves as part of nature. And if you don't buy this thing, buy the statement by Maxwell, the peculiar function of physical science is to take us to the limits of understanding. And on my view, the thing that we understand the less is how do we work or function as a society. Again, let's go to the Greeks. Epicurus already defined natural science. We must hold that to arrive at accurate knowledge of the cause of things of most moment is the business of natural science. So, accurate knowledge of the cause of things. This is natural science, and this is what we intend. In history, normally it is quoted this gentleman, French, Catlett, as a precursor of the study of social phenomena from physical laws. What he was trying to do was to look for statistical laws underlying phenomena, crime rates, marriages, rates, or suicides. And in this book he published in 1835, in his outline, he describes the concept of the average man who is characterized by the mean values of measured variables. This mean or average man continues to be what most economists think about, and, is completely meaningless. Why? Because there are power laws. The mean is not a good concept. So sometimes you talk about to other people saying, we are doing this thing which is new in physics, and they're like, new? Why? I mean, statistics has been used for a very long time in economics and in social science. What is the difference? And if you want, you can go to this, again, precursor of science in historical or in social science. If you look at Asimov Foundation, this mathematician, Sheldon, talking about psychohistory and putting some scientific ideas. Again, it is not about that, because what he was doing is statistics, pure statistics. And statistics is the free gas in statistical physics, no interactions. And if you don't take into account interactions, you are not talking about emergence, and you are not talking about the real social phenomena. So I insist it is not about statistics. It's about emergent phenomena that results from interactions, where in many cases the mean has no sense. I quote there an old paper by this author in Science, in American Scientist. He distinguished three types of problems: simple problems, statistical problems, and complex problems. We are talking here about complex problems, not just about statistics. Okay? I can make here statistics of the height of all of you. There is no interaction in the result of these statistics. So probably a mean is well defined. This I told you before. Now, I also recommend to you this book by Philip Ball, which is very distinguished. He's an editor of Nature, but also a disseminator of science, in which he says why society is a complex matter, meeting 21st century challenges with a new kind of science. I will go here in this paper by him, in which he makes these ideas of universality. He says one of the core assumptions in the study of complex systems is that there exist universal features analogous to those that characterize the notion of universality in statistical physics. That is to say, sometimes the details do not matter. The apple can be red or green. Okay? And going on that, he says, the traditional approach to the social science has tended to view these psychological factors as irreducible components of human social interactions. But attempts to model society using the methods and tools of statistical physics have now provided ample reason to suppose that, in many situations, the behavior of large groups of people can be understood on the basis of very simple interaction rules. Is this idea of universality that I mentioned in the beginning, coming from the golden age of statistical physics. He says, I would argue that their primary value is often to challenge entrenched preconceptions about how human society works. Policymakers are all too prone to linear thinking. Most of the politicians everywhere in the world still think that things are proportional. They do not understand what nonlinearity is about. They assume that we understand how an individual tends to think or behave, we can understand what a population will do. It is surely time to move beyond this ideal gas position and to acknowledge the interactive nature of society that makes it a truly complex and nonlinear system. Let me tell you about, again, that we are not rediscovering the wheel in many cases. Thomas Schelling, which I quoted before, is a Nobel laureate in physics. In physics, not in economics, I'm sorry. He has a wonderful book in 1978 called Micromotives and Macro Behavior. And he states as the aim of his work, this work is about the mechanisms that translate individual unorganized behavior into collective result. This statement could have been written by any by any physicist working on critical phenomena at the same time in the 70s. But there was no communication. And I can tell you an example of the lack of communication. When Schelling got the Nobel Prize, there was an interview. I will later describe the Schelling model of segregation. And in this interview, he says, a long time ago, I discovered, somebody told me that there were some physical models. I think something in crystal formation. It was not, it was in magnetism. Somebody was referred to Ising model, which was a well-known model of, I think, crystal formation, now ferromagnetism. And it seemed to be reminiscent of what I did. And they were interested in whether, if examined in detail, the analogy would be preserved at the local detail of the molecules or whatever it was. There was no analogy. The Schelling's residential segregation model, as I'll explain later, it's isomorphic in the mathematical sense to a kinetic Ising model at 0 temperature with exchange dynamic and vacancies. It is not something similar, related, analogous, no, mathematical isomorphic, discovered in two different kind of people that were not talking to each other. Emergence. I've read that before by Phil Anderson, his general idea of emergence, that the behavior of large aggregates is not to be understood in terms of a simple extrapolation of the properties of a few particles. The same thing was being said by Thomas Schelling. Even inconclusive analysis can warn against jumping to conclusions about the individual intentions from observations or aggregates, or the reverse side. It is the same statement. The individual is not a guide to what happens in the emergent behavior. And what I observe from the emergence, it doesn't allow me to imply something of what happens at the individual level. That social science is a science, I'll give you three examples. Nature, you know what nature is about. I don't know if you know that the Nature group in his editorial policy, it says that it admits papers of all kind of research in natural science. So many people, when they send to Nature a paper on these things I will talk about, the paper is rejected from the editor on the basis that it is not natural science. They are changing because it's a business. But already back in 2007, in their front page, they were talking about social science as the next big thing. It goes beyond journals. Le Monde is, as you know, one of the main newspapers in France and in Europe. And already in 2005, they were talking about a sociophysicist. So that type of thing exists. Next, proof of existence. Physics Today, last year. You have their paper describing what sociophysics is about. And they quote that Paul Grongman said that economics is harder than physics. Luckily, it is not quite as hard as sociology. And we are talking or trying to approach these sociological things. Again, Duncan Batts, which I've mentioned, I think, already 3 times. He talks about this thing as a 21st century science. He says social phenomena involve interactions of large, but still finite, number of heterogeneous entities, the behaviors of which unfold over time and manifest themselves on multiple scales of time and space. This is about complexity and social science. Now, I say I want to study collective social dynamics. The first thing that you will get from many people is, come on, be serious. People do not behave like particles. Wrong. And I'll give you examples. These 2 examples I've shown you before. This is described as particles. People do behave like particles in these 2 cases, which are social collective phenomena. If you want another one, the largest gathering of people occurs every year in the pilgrim voyage to La Mecca by the Muslims in the Jamarat Bridge. Okay, and Dirk Helbing studied these movements, crowd movements, because of safety problems, because there are always people dead. What you see in this little movie here, in green, are pressure waves. And this is described by kinetic theory, in which people behave like particles, creating pressure waves that create safety problems. So it is a wrong statement to say that people do not behave like particles. It is also a wrong statement to claim that people always behave like particles. And those are other examples, which are perhaps more interesting, when people have emotions, incentives, and goals. And this also counts. Examples. This thing here happened in April 2011 after riots in London, that one morning, in a self-organized way, people gathered in the crowds, gathered in the streets, just to clean the streets of what happened a few days before. And that was a self-organized behavior. And of course, there were some goals and intentions. Wikipedia. This is the climax of human cooperation. The question is, Wikipedia, the idea of Wikipedia is not new. People have tried to do that several times in history, and they failed. Now we have not failed. Why? Okay, and there are edition wars. I mean, there are entrings in the Wikipedia which are the result of real wars among the people trying to edit it. Examples are the entry in the English Wikipedia about George Bush, or about the bombing of Dresden at the end of the Second World War, or about the concept of anarchy, which, you know, it's subtle. There are editorial wars, but then there is some cooperation there. I will not show you this video here, but you can have a look at that in this web page. This happened in May 2011 in Spain. I don't know how much you've been following Spanish politics, but at that year, people gathered in the main squares, in the main cities of Spain, protesting about the economic and social situation, and that has changed the political course of history in Spain as of today. And what it is here, it is a video visualizing the tweets that people were exchanging during these demonstrations. And you can see there of how when a demonstration is banned in a given city, how is the reaction in the other city, and how people self-organize in these things. Of course, here there are intentions and goals, but it is the result of self-organization and through the use of this communication, which was Twitter. Now, physics and social science. Who defines the questions? Who defines the good models? I believe that to define the questions, one has to listen to social scientists, but just listen. Which means that then you have to discuss with them which type of questions can be answered. Because one of the roles of physicists is to pose questions that can be answered. And some other questions are, as of today, beyond our ability of answering them. Who decides the good models? What I would recommend is that, if possible, you take a model from social scientists, because then it is accepted. But what you will do with this model is very different of what they are doing with it. What is it about? What problems do we deal with? Problems of competition and cooperation, consensus versus polarization, opinion formation, social structure and group formation, cultural dissemination, language competition, information aggregation, social learning, innovation adoption, socio-technical systems. Those are the type of things that we address. With which tools? Statistical and nonlinear physics, complex networks, game theory. A basic issue in modeling is this thing that people do not behave like particles. There are 3 levels of modeling people in these models. One is of social type. I mean, we model people in terms of Ising-like variables. I don't know, in Argentina, I am Peronist, I am not Peronist, you know, these dual things, okay? Which is a type of social thing. When we go beyond that, in game theory, we have rational agents, and then we have incentives, we have payoffs, and we have strategies. Originally, people were using that, the homo economicus, that's perfectly rational. Now there is some bounded rationality. But here, some strategies came in. And there is a last frontier, which people have started to discuss, but which is this very difficult thing of how to introduce into this model emotions. And the question again is, what are the relevant social ingredients? It is not to put everything we know in the model, but what might be relevant. A few differences between social and physical systems. First, heterogeneity. Any book in statistical physics is about identical particles. We are not identical, right? We have differences, but this can be handled, a distribution of. Then most established statistical physics is about equilibrium. Here we are dealing with non-equilibrium. Non-equilibrium means in physics that there is no Lyapunov functional, that there is not a potential which is minimized or maximized in the dynamics. This is the definition of non-equilibrium, okay? Economists continue to think about optimization problems. And in physics, we do an optimization in equilibrium of a global quantity, a free energy, which is for the whole system. In economics or in social system, they try to optimize local relations. Strategic interactions, expectations, no reciprocity. There is no Newton's third law. I consider Pablo to be a good friend of mine, but he might think differently about me, so I don't know. There is no reciprocity, right? A very important thing, the concept of meaning. We physicists believe, in many cases, that the important thing are the facts. And that's completely wrong and stupid, as all politicians know. The important thing are not the facts, but how people feel about that facts, the meaning they give to the facts. The same fact can have a very different meaning for different people. And politicians, that's what they try to exploit. This is summarized for me in this sentence of Gabriel García Márquez: life is not what one has lived, but what one remembers and how it remembers it to tell, is the meaning. And then is the idea of second-order emergence. Humans can recognize and react to what emerges. And reacting to that, then you modify the thing. Is the idea that circumstances make men as much as men make circumstances, okay? So all these are warnings of when you are dealing with this type of systems, some of the very familiar ideas in physics, you have to take into account that perhaps they have to be modified. The way we describe that is in terms of agent or individual-based models. It means that we have individuals, and then these individuals interact. How do we characterize the individuals? The characterization of the individuals is what we call the state. Beyond the characterization of the state on the individual, then we have interaction rules. These interaction rules is what happens when we interact. The third ingredient is the network of interactions, who interacts with whom. And the last ingredient is the activity patterns, when interactions occur. So every model, in every agent-based models of a social phenomena has these 4 ingredients. And tomorrow I'll describe one of them in some detail. There is this thing which I like, which means that in these models sometimes we are far from reality. What makes James Bond an agent? He has a clear goal, he's autonomous in his decision about achieving the goal, and he adapts these decisions to his rapidly changing situation. I think we are far from taking this type of agents into account. Now, first, the characterization of the agent. I'll give you examples. In models of opinion formation, the state can be binary, as I said before, in the US, Republican or Democrat, okay? +1 or -1. You can have a discrete number of possibilities. This is more Europe. You have several papers, several parties, okay? And then you have one of them. Or you have a continuous opinion between 0 and 1, okay? Which is this model of the Fuan bounded contrast. There are models of segregation, as the one I will discuss later, in which the state is characterized by its segregation between black and white people, black and white, and also your location. Cultural processes, as the model of Axelrod that I understand Pablo told you about, then what you have is a set of non-cultural attributes, a set of tags. infection propagation, discrete attributes susceptible in the infected recovery. And in game theory, an agent is characterized by two things: her strategy and her payoff. Those are the ways of characterizing things. A prototype problem here is what it is called the consensus problem. The consensus problem means to determine when and how the dynamics of a set of interacting units that we call agents that can choose among several options, and be political vote, opinion, or whatever, leads to a consensus in one of these opinions, or when a state with several coexistence options prevails. This is the consensus problem. Okay? When do we agree, or when do disagree continuously? Now, the answer to that depends on, what, as I said before, on the mechanism interaction and the network. Then, the different models that are proposed, what they do is identify one of these mechanisms, isolate that mechanism, and see which are the consequences. Tomorrow I will talk about the outer model. The mechanism is the simple one, which is imitation, random imitation. In the Axelrod model that Pablo described for you, the mechanism is homophily. Okay? And today I will talk about a Schelling model of segregation, and the mechanism there is the threshold for social pressure. Why do I want to talk about this model of Schelling? By three reasons. First, for historical reasons. It was one of the first that was proposed as an agent-based model, and it is a prototype of them. Second, because the model was proposed by a social scientist, not a physicist. And third, because I can show you how this model was described, and when physicists came to it adrenalized by the scent of a new problem, they took over and did new things with that. What is this model of segregation? Well, you know what segregation is about. This was in the 70s. Residential areas in the US were predominantly inhabited by black or by white. Why? How are ghettos formed? What is the common wisdom? The common wisdom answer to that is, well, because white people do not want to have black people in their surroundings, and because black people do not feel comfortable with white people in their surroundings. Okay? Seems clear, common wisdom, we are all happy. Wrong. And this was the question addressed by Thomas Schelling. Is this a consequence of racial prejudice and individual intolerance? And the answer is not. Well, this is just to give you example data from Census 2010. Okay, perhaps New York is more known or clear for us. Okay, this is Manhattan, predominantly white, except here in the very south, an Asian ghetto, north of Central Park, black ghetto, and so on. Now, Thomas Schelling, he says, okay, let's think. Let's propose a model. We have two type of agents, can be black and white, that's what he was thinking, but we can also have segregation between rich and poor, between boys and girls, or whatever. We're going to place these agents on a lattice with a density of empty states. There are empty states where one can move. And let me assume that the agents are tolerant people. What do I mean by tolerant people? Is that if at least a fraction, 1/2 of my neighbors are of my group, I'm happy. That's good enough for me. I only need half of my neighbors to be of my own race. It is rather tolerant, okay? If I am not happy, I move to a free and satisfactory neighboring site. Neighboring is this Morse neighborhood. And this is the simulations by Schelling done with a piece of paper, dimes, and quarters, and moving around. He puts a random initial condition with some empty sites, plays these rules, and he finds segregated configurations. That's what he does. Why is this important? Well, it is a result very robust. Segregation occurs even when individuals have a very mild preference for neighbors of their own type. System evolved from an initially well-mixed population to one that it is highly segregated. And it is not a consequence of individual intolerance. We cannot conclude from the observation of segregation that the cause is individual intolerance. It is an emergent phenomenon.
Sorry.
Yep.
I mean, I understand the history, I understand the connection, everything else. There is an issue here, right, which is that you characterize the emergent phenomena as ones in which, as you put it, there's no conductor. In housing, there are conductors.
Yep.
There are the people who decide who gets to have loans, there's zoning, there's all sorts of other things.
Yep.
And there's an enormous amount of evidence from the social scientists.
I agree.
That the conductors played a substantial role in segregating neighborhoods.
Yep.
And so although what you could argue here is that the prejudice of the individuals who've moved was not the dominant force, you can't conclude that individual prejudice wasn't the dominant force. It's just the individual prejudice of a very specific set of people who decided. No,
let me put it that way, because that comes to the core of the discussion of these things. This is an historical model, as you said. There are other things. What we are trying to do in these models is to isolate a single mechanism and see the consequences of this mechanism. In reality, there are many mechanisms at play. All these models try to start from the very basic, isolate the mechanism and see which are the consequences. And what this model says is that the mechanism of racial prejudice, it's by itself, does not cause, that if we don't have this, how should I say it, isolating this mechanism, we can conclude that if we observe segregation, it is not because of that. It is not because of racial prejudice. It is a consequence of this feedback and amplification phenomenon. It is not individual intolerance.
It could be.
No, for that to be, as you say, you have to add other mechanisms. As you're saying, that there are people in the housing market, things which are not here. Which I say is, you isolate this mechanism, then you can make a proper statement.
But for example, does one have the ambition of having a quantitative theory of segregation? So for example, if models like this produce statistics of the sizes of the...
I'll show you an application. I'll show you an application of that with data in land segregation. That comes back to my previous talk. Understanding, okay, versus engineering and giving quantitative things. We are in this type of game at the level of trying to understand consequences of basic mechanisms. And this is always the question. If I give you a talk, or I don't know, any physical mathematical model in which I say, I have changed that, this is what I observe. I put this new interaction force, this is what I observe. No one protests. If you do that here in social science, immediately there is a question asking you how that would solve a problem of society. We are far away from that. We are trying to understand consequences of isolated mechanisms. This is the answer, okay? So, as you see in my list of why this is important, it is not because that solves the problem of segregation. Because it is a robust result that makes us to understand things, that it was one of the first models to show emergent behavior, and because it has the status of the Ising model in social context. It was very simple, okay? And also, it addresses general questions of mechanism of clustering related to kinetic Ising models, group formation, and the concept of individual threshold. So, there are different versions of these models of Schelling. At least I would distinguish two things. One is long-range versus short-range neighborhood motion. In the original model, was short range, meaning that the agent only moves to neighboring sites. While in realistic models, there is long-range motion. You do not move only in your neighborhood, but you move far away. And then there is the idea of constraint versus unconstrained. Constraint means that you only move if you are unhappy and if you find a site in which you become happy. And this creates frozen dynamics. Unconstrained dynamics, there are several versions, which I describe a few of them, in which there is no requirement on the increase of happiness. Okay? So one has to distinguish between long and short range, constrained and unconstrained. Let me give you an example of what it is short range unconstrained motion. Short range, you only move to your neighborhood. Unconstrained is that unhappy move locally, even if they do not become happy. What does a social scientist do with that? Well, he identifies some parameters and they play some simulations. I'll show you the type of things that they do. They do not write a program in Fortran or C, okay? They use a software, in this case NetLogo. I hope it works. Okay. Then this is a cell 25 by 25, and here I am putting 2,000 agents, which means that placed at random, you have 20% of vacancies. Okay? This is one parameter. The other parameter is your threshold. How much of your neighborhood you want to be happy. Here, I am very tolerant, only 30%. What you will see here when this runs is the 10% of people which are similar and the 10% that are unhappy. This immediately freezes when everyone is happy, and you have some segregation. Then a naive concept is that if people are very intolerant, there will be segregation. To see that this is not true, if I put now my similarity to 80%, and I run it, there is no segregation. It continues dynamically. Easy to understand. I mean, you are so demanding in being happy that no one is never happy, and so everyone continues to move. But if you move this threshold to just 70%, which is still very demanding, you segregate and freeze. What are the consequences here? Well, that these parameters are important, that you cannot make common wisdom statements, and that you have to see how that works. Okay? Good. Then comes the physicist, and well, modify a little bit the model. It's long-range, and it is constrained. Constrained means that you have to be happy after moving, but I accept happy and unhappy can move, which is a sort of noise. Everyone can move, okay? But I only move if I am happy after moving. Again, my parameters are the density of vacancies and the similarity threshold. What you see here is that for different, this is a vacancy concentration of 5%, and you see different characteristics depending on the threshold. This is summarized here, and this is summarized here. What you see is relatively low number of vacancies in 10% and different values of threshold. What you see here is a number of cases in which there is no segregation, but it freezes. Here in the middle, cases of segregation, and then later on, other cases in which there is no segregation. From that, you can construct, then you begin to do some statistical physics. How do I describe these transitions? I have to define an order parameter. The order parameter I define here is a segregation coefficient. This segregation coefficient is defined here. NC is, this is the size of clusters. This is sum over all clusters. This is the weight of a cluster C with NC agents, this PC. You put that here. This is the number of agents. Well, with all these definitions, you construct this parameter here, defined in this way. This parameter becomes 1 when there are two groups, which is full segregation, and it becomes 0 when for a relatively large system you have many of these groups. What you have here is this is for different proportion of vacancies, and these segregation coefficients as a function of this tolerance for these different values. What you see is that in any case, you have two well-defined transitions, from mixed to segregated and from segregated to mixed. Okay? So here you defined an order parameter, you try to be quantitative about these consequences, and you can define transitions. And this is the phase diagram that you obtain. Here is the tolerance, here is the percentage of vacancies. Frozen state, segregated and mixed state, this is what I was showing you before, this first transition, this second transition. For relatively large number of vacancies, you have another transition here to this state and to this one. Just to give you an idea of how these states look, this is this frozen state, which is low tolerance, low percentage of vacancies. That, as you see, it immediately freezes, and there is no segregation. Segregation, the segregated state here, you see that it evolves to a segregated system, and you've been able to calculate where this transition is. Here, this very dilute segregated, there is such a number of vacancies that this is segregated, but with a large number of vacancies. And here you have this mixed state, which is just a system in which you are dynamically evolving. Okay, this is the result. And now, in which sense this is related to statistical physics? This constraint model, that means that to move, you only move to a happy place, so where your tolerance is respected, has a Lyapunov of potential. This Lyapunov of potential is the blue memory Griffiths spin 1 Hamiltonian, which is written here. Okay? The spin takes value 1, 0, minus 1, black, white, or vacancy, and the sum is over nearest neighbors and next nearest neighbor. So the constraint model in which only unhappy move to happy locations, what does it mean? That you only allow motions in which you diminish this energy. So this is a zero temperature dynamics. There is no noise. It's temperature is dynamics at zero temperature in which you decrease this energy of this blue memory Griffiths Hamiltonian with one addition, conservation loss. The number of up spin and down spins are conserved. So what is a Schelling? A Schelling is short range, it is constrained, T is 1/2, this term disappears. So the Schelling model is zero temperature dynamics of this part, kinetic Isaac model, with exchange dynamics, because it is short range, and vacancies. This is it. This is a classical model of statistical physics. When you do a noisy constraint model, you have a sort of noise, which is the motion of happy agents plays the role of temperature. But it's again one of these models. So you see how a very traditional model of segregation in the social literature can be taken up by physicists, put some order in them, and see which are not the analogies, but to which type of models they correspond. Now, this is modeling. Now, there was data, and I will do an intermediate thing. At the end, I will only talk about data. Now, I'll tell you an example of how one couples these ideas of the segregation model of Schelling with data. And I will talk about another type of segregation, which is the land use in the cities. And the data that I will use are telephone calls from mobile phones. What do I do? And this data are from a Spanish Telefonica company from several cities in Spain. I take the city and I make a grid of, I don't know, 100 meters by 100 meters in the city. And then in this grid, I count it says the probability to observe a mobile phone, essentially number of phone calls at different times of the day for different days, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay? And I have this thing for the different cells in the city. What do? I look for the pattern, and I, by inspection, see that there are 4 different patterns. One, in which activities are early in the morning and late in the evening, which are residential areas. Others, where the activity is in the middle of the day, which are business. There are others where the activity is very early in the morning, which is logistics, central markets. And another where the activities is during the weekdays not much, and in the weekday and in the weekends late in the evening. The evening in Spain starts before midnight. It's a crazy thing. And those are nightlife. And from there, I can distinguish these areas in the city. This is the map of the city of Barcelona. I can do the same thing in many other cities. This is the city of Valencia. Now, can I do it not by inspection? What is the way to do that? The way to do that is to borrow from neural science the idea of the functional network. What do they do in brain science is to try to determine when 2 areas of the brain are active simultaneously. And then those that are active simultaneously, they link, and this is the functional network. Okay? You do the same thing here. It is the metropolitan area of Barcelona. You do these recording sites. For each of these recording sites, you have this time series for the different time of the day. And then you do a correlation matrix, a correlation of this signal for this site with all the other sites. This is the correlation matrix. Okay? What does this correlation, when the correlation is high, a Pearson correlation matrix, tell you that this recording, that this activity is similar in these 2 sites. Then you put a threshold, and given that threshold, you say, well, these two areas are active at the same time if the correlation is above this threshold. Okay? And then you create a link. You create this functional network. Okay? And from there, by some method of identifying communities in the network, you do a community identification, and you find that typically there are 4 different communities. And these 4 different communities are associated with these 4 different things. And from there, you obtain the segregation in the land use in a city by use of this functional network. Now, what's the relation of that with Schelling, beyond the concept of segregation? Well, is that we can do a model based on the same ideas. I take one of these cells, and it says that it is satisfied depending on the fraction of land use type among the neighbors. And my model says that logistics wants to be only surrounded by logistics, so repulsive forces to everyone else. That, and this is what I write here, that the rest, night, residential and business also do not want to have logistics surrounding, and that residents of business have some attraction with a parameter that turns out to be relevant. This is important because there are many policies in cities trying to have residential and business in the same place and avoid the US idea of people have residence there, and then we have places with malls for shopping. Okay, and then my global satisfaction is the sum of all the satisfactions of all the cities. What is the dynamics? The dynamics is a Schelling type of dynamics. The model is updated by using random pair of cells, interchanging, exchange their land. If the exchange increases dissatisfaction, and we repeat this process iteratively. Well, this is what you, a random distribution, you calculate these things, and well, you see that as time goes on, you get this segregation. Can we be quantitative about that and see if this is related to what we observe in reality? Well, we do that by introducing a statistical physics concept, which is entropy index. And we do it multi-scale. We do entropy index at different scales. What does it mean? We have individual cells, the ones we're recording, but we divide the city in cells of size d by d, which is the different length scales. So the d is something that I will vary. And for a given division at a given scale, I call Fi alpha the fraction of area of use alpha being logistic, residential, business, in a given cell in the city subdivision at scale A. This is the entropy of this cell, okay? And entropy at scale D is the average of this thing over cell size at this given scale, okay? This is an entropy at different scales. This entropy index divided, plotted versus this dimension, okay? This is in kilometers, so you cannot go for these cities beyond 100 kilometers. It tells you that it behaves very much the same in the 5 main cities in Spain. So you can take the average of that and compare that with a null model. A null model is a model in which these areas are distributed at random. And as you see, this is a good reproduction of the data from this model based in entropy and based in idea of Schelling by segregation. Here we do not segregate people, we segregate the land use. And then, so we had model, mechanistic idea. We have how we mix these models and data, and we go now to the other side of the coin, which in the previous thing I was called even engineering. How do we use data to know things, to have information? And I'll show you the example of geolocalized Twitter data. In my institute, we've been doing data mining. We have now 10 to the 10 tweets stored. In fact, we are downloading of the order of 5 million geolocalized tweets per day, okay? And this is a map of the world with these geolocalized tweets. Geolocalized tweets means that you are sending a tweet, but in your settings, it is set where you are at that point. Okay. What can we do with that? We can follow people. I live and work in this island here in the Mediterranean, okay, which is Mallorca. What we do is we locate people in Mallorca in day 1, and we follow them for 1,000 days to see where in the world they are tweeting. And we see what is the influence of Mallorca in the world.
Are you there? Or?
I don't tweet geolocalized. So this is from day 1, you see how people from Mallorca spread over the world. Most of these are people that do not live in Mallorca, but are tourists in Mallorca. Population of Mallorca is 1 million. The number of tourists per year is 14 million. Okay? You see, well, things like French do not like us, Portuguese do not like us, and well, we had a relatively influence in other places of the world. Now, of course, if you do the same thing with London, the picture is rather different because it's a main hub. But again, you see how people from London, well, first in the UK, all over Europe and all over the world, including Asia, Australia, Japan, the US, South America. So people that at one given day were in London. And since I was coming here, and perhaps you might be curious about that, we could have a look at the influence of Sao Paulo in the rest of the world. You can do that by every city. That's the cumulative thing after 1,000 days. You see influence in Latin America, also in Europe, and well, you see how this spreads over the world. And you can do that with every single city in the world. What's the use of that? Well, it's nice to show movies, but we can be quantitative about that. We can define an average radius. So what is the average distance by someone in one city is moving around in the world. And that gives a measure of global city influence. You have some surprises. I mean, up in the ranking is Hong Kong and Sydney. Well, probably because they are very isolated in the world and they have to move to go everywhere. But third in the ranking comes Rome. New York is not that high. So again, this is being quantitative, being data, giving information. All thing that you can do is to look at the global city mobility network. Which cities are connected with which, okay? And curate communities. Well, this is weighted wide between degree, but essentially you recognize what you would imagine, the clusters of cities which are more connected, Europe among Europe, the US among them, and then, well, you see that, for instance, this is probably Sao Paulo and Rio, and also Buenos Aires, they are rather connected with Europe, and not only with the neighbors from the north. So that gives you an idea of how different cities are connected. An application of that is, here are the 10 most visited touristic sites in the world, and you can see where the people that visit these places, where do they come from, okay? And the Grand Canyon is mostly people from the US, like places with Taj Mahal, even if many from India, it is more widespread distributed in the world. So that gives an idea of how people move. How people move has also to do with migration. And last study done in my institute by Jose Ramasco and co-workers with the support of UNICEF has to see with the migration flows from Venezuela in the last years. What you see in these maps, there are just different zooms. 2015, 2018, Twitter used residents in Venezuela which are detected abroad. Because you have a peak here in their own Venezuela, because that's where they start, and you know how they have been migrating to other places abroad. If you look at that into detail, you have some numbers. And these numbers are good to be which are the validity of other official names, of other official numbers. This is different ways of identifying residents, I mean, different algorithms, and where they are in Brazil, Peru, Ecuador, Colombia, with a total which is close to 4 million people that have migrated from Venezuela. And you see that different forms of doing that are essentially equivalent. This is from the Migration Institute, IOM. That's from the United Nations. That's also United Nations. And you see that here, there is a large discrepancy between this and the numbers in Brazil that we get from Twitter. But you go to the Federal Police of Brazil, and the names and the number they give is much more in agreement with what we observe with Twitter, what it is done here, because those are official names which are not related with illegal type of people that the police has declared. By looking at that, you can also see which are the routes of migration. Okay, and well, this is going one direction and back. It is the Pan American road, which is predominant, so through Colombia and to the south, and then there is the route to Brazil and to the Amazonas. Okay, from here they go either to the coast or back to the Pan American, which is much less important. A different question is, where do these people that migrate settle? Where do they remain? And remain means that they are tweeting, at least continuously, from the same place in 1 month. And what you see here is that Brazil is different. Brazil had many people that go through Brazil, but people from Venezuela, they do not remain in Brazil, okay? Those are the numbers. If you compare with these numbers, means that less than 1/3 remain in Brazil. And this observed number from Twitter and the official names for the different countries in South America, as you see, are well correlated. You can see also the integration. This is the where they settle in the different cities, Bogotá, Sao Paulo, and Lima, as compared with the density of population in the different cities. So this is information that you can extract, and even if you look at the first time they exit from Venezuela, and this is time, you can see how different social or political events give an indication of how these migrations for the first time occur.
You extract this data from Twitter, or just analyzing the tweets of the user?
Okay. Now, this is geolocalized Twitter, but Twitter has also a text, and so you can analyze the text. And this is the one I will not be able to show, or maybe, wait. This web page is wonderful. It's the Tower of Babel that tells you in which language is tweeted from different countries. Okay. Brazil. Obviously, Brazil is predominant, but second is English and much less Spanish. If you go to Argentina, Spanish, English, well, there is a large number of Portuguese. If you go to Uruguay, okay, Portuguese is close to English. And you have different, an interesting thing here is you go to the US, the third most important language, I would never have guessed it, is Tagalog, after Spanish. So you have this information. And then it comes things that have something to see with political issues. You know about these national movements in Europe. This is Brussels. This is Belgium. Blue is tweet in Flemish. French, yellow is tweet in French. As you see, this is a perfectly well-defined border. Belgium is polarized in two communities, the one speaking Flemish and the one speaking French. If you go to Catalonia in Spain, you've heard probably about political movements there, Spanish and Catalan if you want to separate Spanish-speaking people and Catalan-speaking people, you have to go to the north of Vic, up there. But from there below, all the area of Barcelona, all the area of Tarragona, people are mixed. There is no segregation. Okay? You can also do linguistics, looking at the language. And this was a paper that became famous, also from my institute, on Spanish dialects. What do you do? In Spain, which is here, for a car, we say coche, okay? But in the South Cone, they say auto, and in Venezuela and company, they say carro. And same thing for computer. And from there on, talking with linguistics, you can try to identify the different dialects of Spanish. The consequence of this thing was against common wisdom. The two main dialects in Spanish are not Spanish in Spain and Spanish in Latin America, but the Spanish in urban cities and Spanish in rural areas, all across the world. You can do similar things with English. This was a very good title, The Fall of the Empire, Americanization of English. This is, well, you see Europe, the use of British or American, both in vocabulary or in spelling. And you see the British have lost the war even in Europe, both in terms of vocabulary and spelling. And this was using data, 15 million digitized books from 1800, and spelling and vocabulary and how this thing has, American English is predominant, as we know, but this is way of saying this. Another interesting application are ghettos, the identification of ghettos from language use in Twitter. People in different cities form ghettos, and these cultural ghettos are normally associated with language and procedence. This is just a validation of the method. This is the city of Madrid, and this is this is official statistics of people in Madrid, where do they live, and if their language, mother language is Portuguese, and this is from the use of Twitter, and there is a very good correlation that is a validation of this type of data. Then they've looked at cities from all over the world and look at segregation by looking at spatial distribution of language versus a spatial distribution of the population. And there are three groups of cities. The one that, this is the number of languages spoken in a given city. This is London, okay? Then you can create three groups. Here are the cities by colors. One in which there is good integration of people speaking different languages, intermediate, and bad or large segregation. One has to understand these things because both Sao Paulo and Buenos Aires are places where there are linguistic ghettos. But those are the linguistic ghettos of the rich, the ones that speak English. Okay? But they do exist. I'll show you a little movie that explains these results. It has no sound, but I take a 3-minute rest while you read it. One of the things is that the data on migrations is many times flawed by different legal and political issues. And this is data which is under control of no one. So they looked at 53 world cities. This is what I showed you before, validation of that thing for Portuguese speaking. And the use of language identifies these cultural communities. These are the 3 clusters that I told you about. As you see, this is an example of use and analysis of data to get information. While what I showed you at the very beginning was trying to identify what are the consequences of a given mechanism in a model. Well, okay. I think I'll stop here because it's a more detailed discussion of the different languages and this type of thing. Anyway, this was...
So at some point earlier, you were saying that if you look at the distribution of languages of tweets, the United States is overwhelmingly in English.
Yeah, but that was global. I mean, it was the whole United States. While here we are looking at different spatial distributions in the city.
But it even, I mean, the fraction of tweets in Spanish was much less than 10%, right?
Yeah, but still, it is much more significant than when you do a survey. It is, the number is much higher than when people do a survey, which is the traditional way of social scientists. And that's why you need to validate that and see how it compares with official data. This has been, it was taken by National Geographic, and there is a web page in National Geographic in which you can look at these things. Okay, let me see if it's a little slow. This is Mauro's connection. Okay. You see here, this is more integrated, more segregated, the different cities and the different languages. I mean, I don't know if let's look at how people speak in Portuguese. Well, they seem to be very well integrated in Philadelphia, Los Angeles, not so much in Atlanta. They are well integrated in Paris. So that gives you an idea overall. An interesting thing that I found is if you look at all, so you put all here, and then you look at a city like San Francisco. San Francisco was one that was integrating very well different languages. But here, Chinese is very bad integrated. And why? Because there is a very large suburb, Chinese suburb in San Francisco. So they give you this information. So I'm finishing here. You have here some general bibliography of this statistical physics approach to social dynamics. This was 2009. It was a paper in Review of Modern Physics. It was the theorem of existence of the field within physics. And, well, there are different things here. I also, call your attention in this YouTube channel of our institute. There are a very large number of seminars and colloquium that you can look at, many of them in these topics. As examples are social media and attention, large-scale transit systems, languages, contation process, language competition, and this type of thing. And I'll finish here with an advertisement. We are searching for pre- and postdocs in our institute. You have the information in our webpage, so you are most welcome to apply, and if anyone is interested, while I am here, I will be happy to talk. Finish.
Questions? Any?
Speak aloud.
First of all, thank you for the talks. Very, very interesting.
Thank you.
With all of this data, the idea is to propose a Schelling-like model and try to see what the model define some macroscopic observable.
No, let me interrupt you because perhaps I was not very clear. What I did first was to explain what is this Schelling model, which is just consequences of a given mechanism. Second, I made something with the data of telephone that can be used with something related to Schelling model for land segregation. But everything I've showed you with Twitter has no model.
But when you access with the data, the Schelling model, you provide a good fitting, and this can be some kind of validation of the macroscopic issue that you use in the model. With all of this Twitter data, can we postulate a model? If the model is good with this data, this is just a kind of validation of the macroscopic hypothesis of the model.
So far, what I have you explained is what we have done is that use all this data to get information from there, see what we can extract. There are many other things that can be done. Models can be proposed to understand these things. This is why we need people.
So, any other questions? Okay, we have a break lunch, so see you at 2 o'clock.
Maxi.
Dime. Espera que quite esto.
Se había quedado sin batería el micrófono.